4 Thunderbolts tore over the tree line at 420 mph, just 210 feet off the ground. From their first visual to gunfire impact was under 6.8 seconds. In that span, they destroyed 3 Flak 36 positions, a radar truck, and a fuel carrier, all before a single gun returned fire. On the ground. A Flak commander grabbed the field phone, screaming for air support. But by the time the operator connected the line, the only sound left was magnesium fire crackling through splintered barrels. Inside the lead P-47, the pilot had just disobeyed a standing order. Do not dive beyond 40 degrees. Ammo loss exceeds gain. He went in at 52 degrees, dropped into the dead zone, and let the 8 50 cals speak. The others followed. What they used wasn't a tactic. It was a forbidden dive profile labeled wasteful, unstable, and too fast to control. It wasn't meant to be repeated. But after today, the Luftwaffe's frontline air defense began unraveling. Entire flak belts vaporized in under 12 seconds. Belgium-Germany border. November 1944. Strafing run, 4 aircraft, 0 resistance. The manual called it suicidal. 6 weeks earlier, inside a Quonset hut briefing room at RAF Duxford, the room had gone silent. A young lieutenant call sign, Halbert, had just asked the question. No one wanted to hear, sir. Why don't we dive steeper? I mean, 45, even 50 degrees. We're already fast. May as well make it precise. The response was instant. The group ops chief didn't even look up from the clipboard. Because you'll waste ammo, lose visual, and black out on pullout, and then we'll waste time cleaning your teeth out of the wreckage. Everyone chuckled except Halbert. He wasn't joking. Doctrine was clear. P-47 Thunderbolt strafing runs were to be conducted at 25 or 35 degree dive angles. Guns open no closer than a 1-200 yards, pull out no lower than 1,000 feet AGL, with a maximum descent speed of 360 mph. It was a safety profile, not a precision model. But Halbert had flown recon as a co-pilot over Bastogne 2 months prior. He'd seen the way flak belts were being emplaced, tight, clustered, and static. He suspected that coming in high and shallow gave the gunners too much time. So he went to the flight records. He compared gun camera reels. He ran timing on 17 strafing passes. The shallow runs high survival rate, low effectiveness. The steep ones less frequent, more erratic, but when they hit, they neutralized entire battery zones in 10 seconds or less. He brought this to the squadron XO. The answer came fast. Do not bring that up again in open brief. We're not training dive bombers. You're not a Stuka. But Halbert wasn't alone. 2 other pilots had tested steeper angles during October, 42 degree and 47 degree, respectively, using shorter bursts, 0.6 sec, and lower entry altitudes, while on 800 feet AGL. Both returned shaken but alive. The results: 1 fuel truck destroyed, 2 flak gunners killed, a near miss on a command post trailer. The reaction: they were pulled from strike duties for tactical review. 1 was reassigned to escort, the other grounded temporarily for target fixation tendencies. HQ's written judgment was clear. Dive angles exceeding 40 degree offer no strategic advantage. Gun convergence cannot compensate for high-speed, narrow-angle attack. Risk of blackout and control loss increases exponentially. Use of such profiles shall be considered deviation from accepted operational conduct. Unofficially, it had a name, the suicide drop. Unofficially, it worked. But officially, you were told one thing: do not use that. By late October 1944, German Flak divisions along the Siegfried Line had one comfort: left routine. The air war was brutal, yes, but it followed patterns. Strafing runs came from 6,000 feet, began rolling at 30 degrees, and fired from over 1,000 yards. That gave each 80 kite crew at least 9 seconds from visual contact to trigger squeeze, and in 9 seconds. A trained flak battery could traverse, elevate, and fire 2 bursts. It wasn't perfect, but it worked. Luftwaffe doctrine classified the P-47 Thunderbolt as a medium-speed strike asset. Reports labeled it noisy, fuel-heavy, and inefficient against hardened sights. The real fear was the fighter bomber's dive speed, with bombs, but only when coordinated with precision timing and external spotting. Strafing. Strafing was viewed as harassment, not decisive threat. That assessment was already obsolete. Starting mid-September, P-47 squadrons from the 362nd and 406 fighter groups began altering their loadouts. Instead of standard mixed-load configurations, they packed for low-angle penetration 2 500 lb bombs on pylons, 10 high-explosive rockets, and a mix of armor-piercing incendiary API and standard ball in the 50 cal belts. Some pilots customized even further 4 API. 1 tracer, 1 incendiary repeating. Every 6th round ignited steel. But that wasn't the real change. The real shift came in the approach vector. Instead of stacking altitude and bleeding speed, several Thunderbolt flights started their runs from under 3,000 feet, already level and fast, before tipping into a dive at the last possible second. That cut visual warning time for flak crews in half, from 9 seconds to under 5. And then came the kill ratios. In one October sortie logged over the Aachen corridor, 3 P-47s completed strafing passes with no bomb drops and 0 rocket launches, just guns. 5 flak positions destroyed. 9 confirmed enemy KIA. Time on target, 24 seconds total. Ammunition expended 46% of total belts. But the kill report was flagged. Effectiveness beyond expectations. Attribution unclear possible ground explosion chain. The implication? It wasn't the Thunderbolts. It was luck. Flak Command doubled down. They ordered repositioning of batteries, tighter integration with observation posts, and longer readiness cycles. What they didn't realize was that the strength they relied on, centralized, layered flak coverage, was becoming a vulnerability. Static belts meant static maps, and static maps made it easy for returning pilots to mark exact locations. The Americans started flying confirmatory passes using recon bombers at 12,000 feet, logging precise flak clusters and sending them back to fighter groups within 8 hours. But Berlin never got the memo. And when they did, they assumed the photos were flawed. Shadow contrast. Cloud error. These flak belts are not destroyed, they are misidentified. Only they weren't. They were gone. And the tactic that did it, the steep dive strafing run, was still listed as tactically inadvisable. The battlefield sky is math with noise for a flak gunner aiming by eye. Everything comes down to angles, timing, and guesswork. And by November 1944, that guesswork was collapsing under pressure. On paper, the 88mm Flak 36 could engage fast movers with a traverse rate of 24 degrees per second, vertical elevation up to 85 degrees, and a time to fire from lock of 3 to 4 seconds. But in reality, most field gunners needed 6 to 8 seconds to track a moving target from acquisition to lead correction. That window had worked until the Thunderbolt stopped giving it. The new strafing geometry was brutal. Instead of rolling in from 5,000 feet and gently descending at 25-30 degrees, pilots began slamming into their dive from 2,800 feet. No preamble, dive angle 48-52 degrees, entry speed 410-430 mph. The result, gunners had less than 4.5 seconds to see, aim, and fire. Most didn't even get that. A flak crew near Mons recorded the sequence. Observers spotted Thunderbolts at a 1-400 yards. 2 planes abreast, no bombs visible. Warning called, guns began to rotate. 1 second later, the lead P-47 entered a 49-degree dive, triggering gunfire at just 620 yards. They fired one burst. That was all. The Thunderbolts passed over in 2. 1 seconds from first trigger to overflight. All 3 guns were destroyed. The geometry that had once protected the flak distance, height, volume now became a trap. High elevation made the batteries easy to spot. Static placement meant repeated passes could line up on exact map grids. And the gunners' sight lines, designed for slow bombers, struggled to process the speed shift. At 420 point map, a P-47 covered 616 feet per second, from 200 yards out. That gave a flak gun less than 6.5 seconds from first visual to final impact. With a steep dive, that number shrank to under 4.8 seconds. At that speed and angle, any attempt to lead was already too late. Even worse, the P-47s were entering from offset vectors swinging laterally just before the dive to distort aim correction. One pilot described it as throwing my wingtip out at 500 yards, then snapping it back in at 300. Makes a miss every time. The German gunners had no radar locks at this altitude. No automated trackers. Just steel nerves and mechanical aim. And suddenly, that wasn't enough. By mid-November, entire flak sections were being wiped before firing second bursts. And at 12:04 p.m., one crew near the Eiffel Line made the call that stunned Berlin Command. Enemy fighters arrived too fast, fired once, battery lost, request fallback. It was the first time a flak crew had radioed for permission not to fight, but to retreat. The Luftwaffe thought it was cowardice. It wasn't. It was math. Captain Douglas Heller, of the 362nd Fighter Group, wasn't trying to prove anything. He just wanted to stop losing wingmen. On November 2nd, 1944, his flight was tasked with a low-level disruption mission over a suspected flak coordination zone near Prüm, Germany. Intel showed 3 mobile batteries, likely radar-linked, parked along a supply track. Orders were clear: bomb the roadbed, avoid deep dives, conserve ammunition. But Heller had seen too many shallow runs fail. On the previous sortie, 2 of his flight missed their targets, entirely high deflection shots that let gunners survive and reposition. One returned with 14 holes in the wing. One didn't return at all. So on the final pass, Heller broke script. He entered from 2,600 feet, rolled into a 52-degree dive, and pushed his throttle to 98% military power. Airspeed hit 429 meow by the time he crossed 1,000 yards. His squadron mate called out, "You're too steep." Dug. But Heller was locked in. He aimed not for the guns, but for the radar truck. The kill switch. Rounds went out in a tight 0.7-second burst. 650 cal streams converged just as the truck's operator swung open the door. The blast incinerated the entire forward crew. A moment later, the command flak gun rotated, but too late. Heller pulled out at 620 feet AGL. Nose up 11 rear, pulling 4.3 gree, just skimming above the tree line. Back at base, he wrote it up as high-angle overshoot due to wind offset. But ground recon confirmed the result with the radar truck gone. The remaining guns fired wildly unsynced, scattered, then silent. One was found abandoned. Another still had unspent rounds loaded. The ops desk wasn't impressed. They flagged his dive as reckless, his trigger burst as wasteful, and issued a note: "Captain Heller is reminded of regulated dive angle ranges, 35-degree max unless under dive bombing profile." But something had changed. 2 days later, he tried it again. Slightly lower 48 degree. Hit 2 trucks this time. Result: full battery knockout in 8.1 seconds. Still too fast for accurate enemy return fire. Still outside doctrine. Back at Group HQ. The after-action report included a footnote from Intel enemy flak: performance degraded. Battery-to-battery handoff failed. possible loss of comms relay asset. They still didn't credit the dive. They credited confusion, malfunction, weather. But on the German side, things were clear. The gunners were not confused. They were dead. Berlin ordered redeployment of mobile, flak spread positions wider, pull back from roadbeds. But that opened another problem: coverage gaps. The P-47s weren't slowed. They just came in wider and lower. And on November 6th, the Luftwaffe tried its first serious adaptation. It started at 900 feet, and it forced the Americans to break their own rule again, this time mid-fire. On November 6th, 1944, the Luftwaffe began testing a new flak trap design east of Bitburg. The change came fast: less centralization, more deception. Crews were ordered to reposition guns into staggered tree lines, use canvas mock-ups, and limit radar emissions. Most critically, mobile radar trucks were decoupled from gun clusters, operating from over 900 yards away. This added delay, but also bought them time. The U.S. had just 4 P-47s tasked with a low-angle sweep of the sector. Among them, first, Lita. Paul Drayton flew Thunderbolt serial 42-27687. He'd flown 6 prior missions. 0 hits taken, 0 damage. He was confident, too confident. They approached at 3,000 feet, descending into a 47-degree dive, but this time the enemy was ready. As Drayton rolled into his dive, he saw the same setup: exposed trucks, light movement, textbook target. He began his run at 426 mpm, targeting what appeared to be a radar vehicle, opened fire at 950 yards, fired a 0.9-second burst, and prepared to pull out at 680 feet, but just before crossing the 700-foot mark. 2 flak bursts detonated to his right. The enemy hadn't been at the road. They were dug in farther back, covered by scrub. A 3rd burst hit. The shell pierced the left stabilizer. A fuel pressure alarm lit up instantly. Airframe trembled. Drayton pulled out hard 4.8 G, banked left, overcorrected, and nearly entered stall. He was down to 198 map at 320 feet, when his right wing caught turbulence from his own smoke trail. He stabilized at 275 feet, but couldn't climb. Behind him, his wingman took a hit through the canopy frame, but made it out clean. The new tactic worked. The German crews had shifted their aim zone. Instead of tracking dive lines, they pre-aimed along offset vectors, targeting common escape arcs. It was a simple change aim where they'd pull out, not where they'd dive in. That shift added nearly 2 seconds to their firing window, enough to get 3 bursts out instead of 1. Back at base, Drayton's Thunderbolt landed hard. Fuel leak along the wing route. Stabilizer nearly torn loose. Gun cam footage showed no confirmed kills. HQ logged the outcome as inconclusive effectiveness. Unofficially, morale dipped. Suddenly, the angle wasn't invincible. The dive couldn't guarantee a kill. And now, the Germans were hiding their radar units and baiting the first pass to spring flak crossfire from the 2nd tier. Pilots began hesitating. Some pulled up early. Some switched back to 35 louder dive runs. Accuracy dropped by nearly 60% in the next 3 missions. The tactic had met its counter, but it also made something else clear. If you went in steep now, you had to finish fast or die inside their zone. And on November 9th, one pilot miscalculated. The dive was too slow, the pullout too wide, and he nearly blacked out at 180 feet with the right wing already torn. The mission on November 9th, 1944, was supposed to be routine 3 P-47s from the 406th Fighter Group, sweeping a flak-heavy crossroads outside Kilburg, where German supply trucks were reported regrouping. The weather was marginal low ceiling at 5,200 feet. Visibility less than 4 miles in haze, but orders stood. Target grid confirmed. Dive runs authorized. Captain Alan Red Thomas led the flight, experienced, careful, but ambitious. On his 17th sortie, he'd been watching others pull 45-degree and steeper dives for weeks. He decided this time he'd go sharper, just once. The descent began clean. Entry altitude 2,900 feet. Dive angle 49 degree. Airspeed built faster than he anticipated. 441 MWI at 1,000 feet. But something was wrong. He opened fire at 700 yards, targeting a suspected flak gun near a hayrack. The gun position was real, but had already been abandoned. Decoy. The real flak fired from the right, hidden in a sunken field behind the road. The first shell hit the right wing root. A second burst blew through the rudder linkage housing. Thomas felt the jolt. Then the controls went soft. Airspeed, 465 mph. Altimeter, 390 feet, and dropping. Oil pressure began to flutter. He pulled. Nothing. Trim wheel spun uselessly in his hand. Elevator response delayed by nearly 1.4 seconds. An eternity in a dive. He forced full stick back. G-load peaked at 5.2 GRE, and black closed around his vision. He remembered hearing his own breath, ragged, panicked, shallow, then impact. But not with the ground. The P-47's belly smashed through the top of a hedgerow at 182 feet, tearing the ventral access panel and scraping 2 feet of skin off the underbelly. The main wing spar held but barely. Thomas came to at 520 feet, still descending at 190 if to min. He kicked the rudder. Nothing. Sluggish left bank. Right roll unresponsive. Elevator pressure required 2 hands. The engine whined under full power, but RPM had dropped to 1950 down from normal cruise of 2,550. Back at the field, observers watched as his P-47 limped home. Low and weaving, trailing smoke from the right side, he landed hot at 136 mph, overshot the first third of the runway, blew the tail wheel, and coasted into the grass. Crew chief counted 3 flak holes through the oil line, 1 shattered elevator rod, and fuel pressure hovering at 9 psi. Normal was 14. They'd almost lost him. The review was blunt, dive angle unsanctioned. Pullout initiated too late. Rudder failure combined with overspeed trim lag resulted in near-fatal blackout and structural damage. Thomas didn't fly the rest of the week. 2 other pilots requested dive angle clarifications. 1 squadron reverted to 35-degree standard, pending further intel. The tactic now looked like what HQ had always warned. It was working until it wasn't, and back at the front, the Germans believed they'd won. Then came the reversal. 1 pilot re-entered the dive zone, damaged, low, with no trim, and pulled off the impossible. It happened at 204 feet. The maneuver that followed wasn't written down. No handbook taught it. But among the surviving pilots of the 362nd and 406th, it became legend, a hybrid of desperation and math, born in the final seconds before blackout. Pilots called it the snap flare punch. On paper, it violated every principle of stable strafing. In practice, it saved lives and confirmed kills. Here's how it worked. Standard strafing procedure called for trigger squeeze at 1,200 yards, dive angles under 35 degree, and pullout at no lower than 800 feet AGL. This gave gunners 6 to 9 seconds to react, but it also protected the aircraft from stall risk and G overload. The snap flare punch flipped that rule. Entry altitude 2 400 to 800 feet, dive angle 4852 to green, trigger distance 750 yards, pull-out floor under 500 feet, timing window 2.2 to 2.6 seconds from fire to exit. It required violent nose-down entry, minimal rudder adjustment, and a compressed burst, 0.5 to 0.8 seconds max. The goal wasn't saturation, it was decapitation aimed for the lead truck, radar mast, or exposed gunnery crew. Fire just long enough to ensure burst impact, then flare out. The risk came at the flare, at 400 plus was MAP. Pulling from a 50-degree dive required 3.8 to 4.5 G sustained force. Pilots needed to ease out over a 600-700 FT recovery arc, keeping angle of attack just below stall threshold. Most pulled out at 10-12 degree nose up, while throttles stayed above 85% power to maintain airflow over the stabilizer. One mistake, overpull, and you stalled flat, underpull, and you hit dirt. But the geometry made sense. At that angle and closure rate, enemy gunners had less than 4 seconds of reaction time. The offset dive line also disrupted range finding, leading to overshoots or premature fire. In one debrief, a pilot described it like this. It's like falling out of the sky sideways. You punch the nose, fire one breath, and yank just enough to stay alive. You don't look at gauges, you feel it in your spine. If your vision starts to fade, you're doing it right. To execute it. Pilots often trim nose down before the dive to reduce stick force in recovery. Some disabled elevator trim entirely during the attack to avoid delay. Others adjusted their gun belts, stacking incendiary every 4th round to mark impacts clearly. There was no official training cycle. It was shown peer-to-peer. One pilot would fly the maneuver on a dummy run. The others would watch from below. No one spoke during the climb back up. And yet, results proved hard to argue. Hit rates climbed. Pass times dropped under 10 seconds. One squadron logged 5 confirmed kills in a single run using nothing but guns. But it came at a price injury, airframe damage, blackouts, and if you mistimed it by even a second, you'd break your back or tear off your wing. Still, one pilot decided to try it mid-damage, mid-run, at 204 feet with half trim and no rudder. That's when the flak guns fell silent for good. November 11th, 1944, 09:42 hours. Captain Drew Whitlock's Thunderbolt had already taken a hit. A 20mm flak burst near the right wing had torn into his aileron linkage and cracked part of the main spar. He should have climbed out, regrouped. Instead, he turned back toward the tree line. Target a newly repositioned flak site southwest of Prum. 3 guns confirmed. 1 radar mast, 2 camouflage trucks, estimated crew size 16 to 20 men. Whitlock had 48% ammo remaining, left rudder sluggish, trim wheel barely functioning. His P-47 was still flying, barely. He rolled in from 2,600 feet, adjusting pitch manually, no trim assist, dive angle held at 50 degree, nose heavy, speed climbed, 381 more maps at 2,100 FT, 402 MEPI at 1,600 FT, 427 MEPI at 1,000 FT. He reached 700 yards from target, gun selector toggled, to inner 6 barrels. Countdown began 3.0 sec, open fire, burst length 0.68 seconds, 50 cal rounds API and tracer struck the radar mast and front truck. 2.3 sec, Whitlock adjusted nose by 4 degrees. Fired second burst, 0.5 sec. Lead flak gun ignited. Gunners thrown clear, 1.6 sec. A third gun opened fire but missed low. Whitlock offset by 12 degree roll. Right wing pulling harder due to damage, 1.2 sec. Final burst, 0.6 seconds. Caught second truck engine block and likely the fire director crew. 0.9 secs. Pullout initiated. Stick full back, no trim. Left rudder useless. G-meter hit 4.3 G. 0.6 sec. Vision blurred. Speed 437 mph. Altimeter reading 460 FT. Sinking at Mach 250 min. 0.3 sec. Whitlock shifted full throttle forward. Supercharger kicked in. Airflow over tailplane increased. Nose began to rise. 0.0 sec. Aircraft passed tree line at 204 feet. Leveled out with less than 3 degree line margin to stall. Engine temp at 287 degrees. Oil pressure just above minimum. Total time on target 11.4 seconds. 3 flak guns silenced. No return fire after the 8-second mark. Radar mast destroyed. His wingman called over radio. "You still alive?" Whitlock didn't answer. He was regaining vision and blood had drained to his legs from the high G pullout. Later analysis showed 61 rounds fired, 5 direct hits, and at least 12 personnel casualties. One truck was still burning when recon passed over 11 minutes later. On the ground, the flak crew survivors did something unprecedented. They ran. When infantry arrived to reclaim the site, they found equipment, rations, and radios left behind. The command unit had simply dropped everything and vanished. Why, one prisoner later told his interrogators, it wasn't the plane. It was the silence after, the kind where nothing moves. You hear a shriek, a hammering, and then it's all gone. We weren't ordered to surrender. We just did. The maneuver that manuals banned had just broken a flak division, and it spread. Pilots who watched the footage copied it. Within a week, 5 more runs used the same dive pattern. But success triggered a new threat. On November 13th, German interceptors returned to the sector. They weren't hunting bombers. They were hunting Thunderbolts. Captain Whitlock leveled out at 204 feet. But the Thunderbolt wasn't flying clean. The ailerons were twitchy. His rudder was effectively dead, and his coolant temperature had spiked to 287 degrees Celsius, well past combat threshold. Fuel reserve was down to 18%, with one tank registering erratic flow. Gun belts were spent, 0 rounds left. He was alive, but in the worst position, a pilot could be low, damaged, unarmed. Then came the call from his wingman. 2 bogeys, 5 o'clock low. Moving fast. Whitlock looked back. 2 FW-190 A8s, altitude climbing fast, roughly 1,800 feet behind and closing. Luftwaffe fighters hadn't contested the sector in 2 days. Now they were back. He had one choice, climb or coast. Climb risked stalling, with his elevator only partially responsive. Coasting meant a long, flat exit across open terrain with no cover. He banked east, altitude just above 350 feet, using tree lines as a visual shield. His engine RPM sat at 2,050, well under rated power, but it was holding at 4.2 miles out. The 190s had line of sight and committed. Whitlock jinked left, then cut throttle 40% to induce an energy drop and throw off their lead. The 190s overshot by just over 90 yards. A rookie move from one of them overconfidence. He pushed throttle full again, supercharger engaged. Airspeed climbed 276, 293, 308 mph, enough to deny a second pass barely. Back at base, crew chiefs waited. When Whitlock appeared over the ridge, trailing smoke, gear partially down, left wing dragging lower than right, they scrambled the flare crew. Touchdown came at 132 mph, too hot for the field's wet strip. He bounced once, then skidded off the runway edge. Final stop just shy of the fuel dump by 23 yards. Inspection found the right wing had taken 5 holes, including one that nicked the ammo chute just above the hydraulic line. The gun bay had cooked 2 belts from overheat. Engine was 15 hours from failure. Flight surgeon noted blurred vision, bruised chest from G-lock, and left ankle sprain rudder pedal impact. But Whitlock survived, and the mission had confirmed what no one wanted to admit: steep dive gunnery. Once dismissed as wasteful, had now silenced an entire flak sector in 11 seconds. Yet the price was rising. Engines were overheating. Ammo was vanishing before the pullout. Pilots were finishing empty and blind. And now, the Luftwaffe was redirecting interceptors to low-altitude strike corridors. The airspace was changing again, so command issued a choice: conform to doctrine or assume personal liability for damage. Unofficially, the message was different. If you can end the belt in one pass, do it. But don't miss, because they'll be waiting now. The final run of the week would be the last steep dive flown without full squadron approval. The pilot who flew it had already been grounded once, and he was about to fly without clearance again. November 14th, 1944. Base Command at Chevres Airfield had already posted notice all strafing runs were to be conducted under revised angle limits, 35-degree maximum. No exceptions without squadron leader sign-off. Maintenance reports showed too many bent airframes, too many scorched gun belts, and 3 Thunderbolts now grounded with control cable overstress. So when Lieutenant Mason Riley requested a dawn sortie and didn't file a dive plan, nobody caught it. At 0741 hours, he lifted off solo under cloud cover. Objective confirm last known flak cluster near Burbach, same zone where Whitlock had flown. Riley's previous record was spotty, aggressive, disobedient, but effective. He'd been grounded once for breaking formation in a combat box run, but unofficially, crews trusted him. They said he flew like he was already on fire. Riley arrived over target at 0819, altitude 2,700 feet. Visibility clear. Recon said the flak guns had moved. But Riley spotted them barely, camouflaged beneath tarps. 288 sat in ambush behind a fuel dump. He rolled in. 51 aground angle. Entry speed, 412 MEP. Gun camera engaged at 720 yards. First burst, 0.6 seconds, clean impact. The tarp ignited. Second burst hit a lead gun's elevation mount. Third burst short, aimed left, hit the fuel truck. At 08:21:07, the fuel exploded. Flames spread into the supply tent. Ammunition cooked off. By 08:21:13, all 3 flak guns were silent, either abandoned or destroyed. Riley pulled out at 480 feet. G-load hit 4.6, nose up, 11 degrees. Throttle pegged. Damage minor. Radio still working. He called it in strike complete. No return fire. No survivors visible. He landed at 0856 fuel at 12%. Temperature at limit. Crew inspected. No hits. No stress fractures. Flawless run. The gun camera was sent to command. And then nothing. No debrief. No kill confirmation. No recon follow-up. The next morning, Riley checked the operations log. The mission was missing. Not delayed missing. His flight wasn't listed. His kill footage not logged. He asked the photo officer. The answer came quiet. They pulled it, said the dive was unauthorized. You weren't cleared to engage. Later that week, Riley's sortie record was revised to recon only no enemy contact. But word spread anyway. 3 crew chiefs watched the footage before it vanished. One of them made a copy. By the end of the month, a dozen pilots had seen it. The moment the fuel truck went up, the full 11-second sequence. No mistakes, no bounce, just a clean, steep dive that erased the flak nest and left no one to man the guns. And that's when pilots stopped asking for permission. The tactic was banned in training, erased from reports, and condemned in post-mission summaries. But in the air, it lived on. One pilot whispered it best. They tried to erase it on paper, but not from the gun cams, not from our hands. And those hands kept teaching it off record, because by then, it wasn't just a move, it was survival. By December 1944, the steep dive tactic had no name. It had no manual, no diagram. But it had a legacy in fuel stains, cracked stabilizers, and flak belts gone silent. And it was spreading. Pilots began flying practice dives off target, just outside recon zones, pretending to check terrain or adjust compass. In reality, they were watching each other, timing the angle, measuring flare altitude, peer-to-peer training, no clipboard in sight. In the 406 fighter group, gun camera footage of Captain Whitlock's run was duplicated 6 times and passed discreetly between squadrons. One copy was mailed back to the States with a note. This one ends them. Instructors at forward airstrips began adding unofficial remarks during briefings. If it gets tight, steepen. Just don't tell me you heard it from here. If your target doesn't fire, dive harder. If it fires early, flare later. And most telling of all, you get 1 second to live or die. Choose when to spend it. The tactic didn't change the war, but it changed the math. Kill rates for low-level P-47 strafing rose by 23% between November and January. Damage rates held steady, but return fire dropped. Flak crews started burying assets deeper. Some sectors began camouflaging radar units underground sign of fear. Not doctrine. A memo intercepted in February 1945 from a German Flak commander stated, "American ground attackers now enter too steep, too fast. Warning times ineffective. Engagement is suicidal without Luftwaffe cover." Back in the U.S., stateside training manuals were quietly revised. Page 38 of the 1945 Fighter Gunnery Guide included a new line under Approach, Profiles Note. In some field conditions, steep angle, high-speed profiles may offer precision advantage. Caution advised, not suitable for novice pilots. It didn't call it what it was, but instructors knew, and by the time the war neared its end, new pilots arriving in France were already hearing the whispers. Not from officers, from crew chiefs, from men who'd seen the footage, who'd counted the seconds, who knew that sometimes survival came not from altitude or ammo, but angle, unofficial, unsanctioned, unforgettable. Captain Drew Whitlock flew 3 more missions after the 204-foot pullout. On the last one, his Thunderbolt's engine seized mid-climb at 7,400 feet. Not from flak, but from a fractured oil line weakened during his famous dive. He bailed out near Uskirchen, was picked up by friendly troops, and returned to base 72 hours later, limping but alive. His aircraft P-47D serial, 4226799, was stripped for parts. The dented wing spar was never repaired. The logbook ended with one line in red, "Final dive exceeded limits. Airframe overstress. Do not return to duty." Whitlock didn't fly combat again, but pilots who trained under him did. One later flew the same dive profile in Korea, different plane, same angle. Another taught it quietly at gunnery school under the term delayed pull short burst. The maneuver itself never earned a name, but it passed from hands that needed it to hands that survived because of it. The flak belts that once ruled the skies west of the Rhine never fully recovered. After March 1945, most were abandoned without firing a shot, because too many crews had seen what happened when a Thunderbolt came in steep, silent, and didn't climb back out until everything was on fire. That wasn't a mission. That was a message. And it started with a forbidden angle. Not one drawn on paper. One cut into the ground at 50 degrees for just 11 seconds. Over one truck that shouldn't have mattered but did, because it showed what happened when rules broke and pilots didn't